So we'll continue with the third video about the greenhouse. And I talked about the plastics, and I was cut off because there's no room on my phone to record. Anyway, so the leaching from the plastic with this HALS and benzotriazoles, what are called, it's so little, and it's so little taken up. And in the animal studies, you had 10 milligrams per kilo for years, or to show any harm. And in this case, it will be just nanograms, so like 1,000 of that. And I will use a lot of biochar in the soil, so much will be captured there. And it's broken down. It has a half-life of like, depending on how much sunlight and oxygen it gets, they get the leach from the plastic around half a year, something like that. So whatever comes out breaks down. So yeah. Anyway, so I built this kind of flat roofed greenhouse before, and I could, if I would go up here and stand on this, I could stand on this because the plastic is so hard or steady, or how you say. It's like you cannot pull it apart. It just gets, it's like this old beer, what's called beer plastic that you have to pull and pull and pull, and it just holds together. So anyway, but I will anyway keep the snow level here inside on top, low. On the other flat panel greenhouse I built a small one. It kind of melted away by itself because the sun comes in from the side and heats up inside more often, so it's above zero, and it melts the top, and the snow kind of decreases more than on other roofs. So it can get like a meter, 1.5 meter here, like 3 to 5 foot of snow or even more. So that's kind of get really heavy. So I built this extra stabilizing beams here. Before I could shake it, but the more of these I built, especially those on the sides, I cannot rock it even now. To make it last longer, there's no foundation, so I just burnt the ends of the logs. This is pine and spruce. So every second one is smaller, the corner ones and the big. So like those smaller ones are actually not meant to be there, but I just put them there anyway. So for the plastic to not move in and out, and it was kind of good. Smart idea. Anyway, so they are burnt, and this will make them last longer, because it's not a permanent setting, even though the fire stove here, or say the rocket stove, is kind of permanent, but it could be outside anyway. It's like in a sauna or whatever. So and as a second thing, I wanted the compost, big compost to heat everything inside, because it's a bit warmer here inside now than outside. It's still minus inside. You see the snow hasn't evaporated from this log here, or this wooden stump. So this self-burning compost, I wanted to make this big enough. It's shrinking down, but I don't feel any special heat from it. Maybe it's causing a little of heat, but it's leaf, grass, and millstone. So I thought this to kick it off, like in the really cold times, like now when it's minus 10 outside in 25th of November. I wanted to have a wood stove, which I failed with kind of like now, because I didn't get any good drag in it. This pipe is too small, so this is a rocket mass heater, and it's not finished built. The pipes and everything inside is pretty large, or diameter is pretty good, but this chimney out here is too thin. It's like 10 centimeters, 3 inches or whatever, 4 inches. and this is maybe the reason. So I'm gonna switch this one out. I put it into concrete here, and it held was tight. There's some small leaks outside. Anyways, I will replace this with a much larger tubing, and I should have used this before, maybe inside instead of using cement to make the tubing. This is aluminium pull-out tubes, 3 meters each. So we have 6-meter chimney. I will use this log to keep them straight. It's not optimal, of course, but it won't get so warm that it melt or anything. The smoke will be under 100 degrees. When the smoke comes out now, it's just, I can't feel it anyway. It's so cool. So all the heat is stored in the system, and it burns so slow because it's so the flow is so bad now. But anyway, so these are same price. So this is a recommendation. This aluminium, I don't know how they will corrode or whatever, but I can change them later. This for this winter and spring to keep it warm and get a good start. So I will try to put this up now. I will weld them together with aluminium tape. I put concrete around. They will go out there. I don't think I need any stone wool to keep it cool, to not melt the plastic. But yeah, so it gets under 100 degrees at least, or less, even less, because much will be captured in here. It's like in the end when you make the fire for a long time, I guess it's a problem. So then I see if I put something new around there. So it's kind of hard to get stuff through the top. Anyway, so the plastic is just on the top is 3 rows, 1, 2, 3, and then on the side is just one continuous upper because it's 2.7 meters, and then in the bottom I cut it in 2, so it's a half width roll used for around it. And then I built the door before, so when I put on the plastic, I nail everything together, and I just cut out the sides of the door so then I can open it. And it's kind of easy because I used like all the wooden stumps, cut them in 2, split them in 2, and then use them as 3 nails to fixate the plastic. And then in the top, so it tilts down to the top, and everything will come out and drip out in the middle in a hole, and it drip down into here. This hole will be a fence around it, kind of maybe 0.5 meter, and then a big plastic bag of the same material. I will seal it with a heat gun, or I say it heat welder, and that'll be like a 1.5 to 2 cubic meter of water here to use in the greenhouse. So all the rain will be collected and then can be used inside with some pump maybe even, and tubing to feed whatever is growing here. So yeah, that's it. So when I built it, I just put the post down first. I put a rope with a liner to make it straight. Then just a chainsaw and just cut all of them, and then I start building, adding the new wooden on top. So when that was done, I added those inwards one by one, and then I used the extra ones to steady them. It was a lot of cutting, but with a chainsaw it goes pretty fast. And so all of this is collected here, just dead wood that's going to be burned anyway. The plastic was 3.5 rolls, say 4 rolls, $150. The barrel I got for free. I just asked at the mechanics shop. The plastic, of course, the black plastic I bought already. It's like a roll. black and white. One side is white, other black is used for growing strawberries or whatever out of. Yeah, the cement, of course, is the expensive part, and the tubing costs some as well. Yeah, so it's kind of just the time and work is time of work is the price of that. If you think of time as money, is the spent. Otherwise, it costs maybe say $250 all of this. Yeah. So, or maybe I say $300 then. Yeah. So that's. I don't know if it lasts the winter. Probably. It's I never seen this type before, like a flat paneled roof. And I thought from the beginning it was great because it just make holes in it and drip inside, but to keep the heat. Now it made it like tilting a bit inwards to to collect the rain in one hole instead in one place. So it's like a roof tilting inwards instead of going down instead of up. Yeah, and then compost heating and burning wood to heat it, to burn off or melt the snow that will come on top now. There's some mice and some other problems. Soil is kind of good anyway. I will mulch it and use the compost for it, and then biochar. I hope the compost will heat. It's not maybe. I hope it will work. It's not science yet. It's just hope now, and take it from there. So we'll grow. Could grow like for 2 months extra, like the summer extended 2 months with this type of greenhouse in here. Produce a lot of food that couldn't otherwise be grown at this height, we say latitude or whatever. Yeah, but now it's a construction place at the moment. Also the compost is there to protect the plants I planted there. I planted some kiwi. I don't know, this tree is Persian or what it's called. Good stuff. Fig tree and blueberries. And I hope they survive this mini kiwi. And the heat from the compost was supposed to keep them warm. But now, it got really cold. So 10 minus, I don't know in Fahrenheit, what you say, Kelvin, or have to learn that. But yeah, you in Canada maybe understand. US not maybe. Anyway, it's freezing at 0. So, and you see the water here was still, even though it's minus outside, it was water, but now it's frozen. So it's really cold. Yeah, I will maybe do more movies here, videos to update you on this one. I covered with a lot of soil. I will take the soil or the sand from here, stones around it, make it a huge pile to be heated up, and then figure out how to make the compost burn faster. I added nitrogen to it, a lot of nitrogen. You want a special ratio of 30:1 with carbon, and now it's lower. But I see in these wood chip stacks in the forest, we have a really low, like 1 to 100 or 1 to 200 nitrogen ratio burn, self-heat by themselves, and even start to burn with a fire. And that's so it's possible to get it hot anyway. But I should have a system to turn it. In this case, I cannot. So we'll see what happens there. I just kind of winged it, how do you say, hoping it will work. And we can look outside where it's snow now. It will melt away. Right. and he wants to throw the stick. Sun is out, not the optimal place because the sun is covered by wooden trees in the winter. It's kind of like a high wall of trees covering, or this forest covering the sun. They only get sunlight in some parts of the day now, but I will do the best of this now, and yeah, maybe post a video soon to update how it goes. Bye bye.